Dear IGCSE students everywhere, hi again. We finished last part, mensuration 2, the second part of mensuration. Today we are with very important lesson in mensuration 3. We are continuing with the surface area of the basic 3D shapes. We'll start with the surface area of pyramids first. Pyramids. We finished last part, and if some of you, my specific students or any student around the world, I wish you all the best, did not watch the previous video, watch it please. Watch it to catch up easier what's happening now and later on. Okay, we'll start with calculating the surface area of a rectangular pyramid. Rectangular pyramid. And I'll give you homework at the end. I will do the harder one. And I'll give you homework at the end of the lesson, squared-based pyramid. So you understand, which are both expected to be past paper questions and exam questions in the coming exams, in the IG exams. Alright, let's start explaining how do you calculate the surface area of a pyramid. We know that the surface area of the pyramid depends on its type. Depends on its type. Since the pyramid that we are doing now, its base is a rectangle. Its base is a rectangle. Four-sided figure, rectangle. So it has 4 triangles. So the area, my dear students, the total area, surface area of this pyramid, its area of its base, which is a rectangle, easy, and 4 triangles. But these 4 triangles, they are 2 pairs of triangles as well. 2 pairs of triangles. Because the rectangle is, each 2 opposite sides are equal and parallel. If this 6, CB, which is CB is 6, so DA is 6. CD is 8, so AB is 8. So we have 2 isosceles triangles. 2 triangles, 2 pairs of isosceles triangles. So we have to calculate the areas of one of these, of each pair, finding the areas of the 4 triangles plus the area of the rectangle, which is 8 length and 6 width, which is easy to all of us. The idea now, the challenge, is finding the areas. To find the areas of the triangles, as I did to you here in colors, in red. The triangle, first one, it's FBC. FBC. Its height is H1. Do you see H1? The triangle FCD, identical to FAB. So it's enough to find one of them. 1, 2. Do you see them? FCB, it's the same with FAD. FCB, it's the same FAB. So it's enough to find the area of one pair, one triangle of the 2 pairs. So that will be written here. I helped you in writing. So the first one, rectangle plus. I did sketch it to you to make this lesson easy to you because it's challenging of many students, or for most of students. So I'll make it simple as I can. So the first, this means 2 triangles, this language, 2 triangles. Each triangle, its base is 6. Look, this is 6 times H1, which is its height. Plus 2 triangles. This one, FDC, and FAB, its height is H2. So, simplifying this for this step here, 6 times 8 is 48, plus 2 with half will be gone, so 6h1 plus 2 with half will be cancelling each other's, 8h2. So it's enough only to find h1 and h2, h1 and h2 to find the surface area of the pyramid. How do you find h1 and h2, my dear students? To find h1, we have to look well to the shape. We have to find dp first, db first, db. db is the diagonal of the rectangle ABCD, the diagonal. So ABCD is a rectangle, DB is diagonal or a diagonal to the rectangle. So ADCB is right angle triangle. So DB by Pythagoras equals 6 squared plus 8 squared. By squaring root you will get 10. You will get 10. Why we find DB, my dear IG students? To find EB, this one, EB. EB is 5 as well, that I wrote to you in blue, by properties of the rectangle. It's a characteristic of the diagonal. This is the height of the pyramid. It bisects the diagonal of the rectangle. So this is 10, so this is 5, and this is 5. Again now, the triangle FEB, as I wrote to you here, the triangle FEB is right at E. Since the triangle FEB is right at E, because the height of the pyramid makes 90 degrees to the base. It's perpendicular to the base. So FEB is right angle triangle. So FB is the hypotenuse of this triangle, yes? So again we do Pythagoras Theorem for the second time, which is 12 squared here, focus here, plus 5 squared, squaring root, you will get 13. So this which is called the slant height. This is the slant height. We are finding it to help us to find h1 at the end. This is the idea to find the surface area of the pyramid. After finding this 13, what I will be having, I sketch this outside to you to see it again. Now the last step, we know now sufficient information now in the triangle that we are finding its height, that I called it h1 from the beginning, which is FBC. FBC, its height is 6, its base is 6, its height is h1. We know now, since FBC is an isosceles triangle, so its height bisects the base as well. Bisects the base as well. Bisects the base, cut it in 2 halves. If some of you are not familiar with the word bisect, cuts 6 into 2 threes. So what do you have now? Look here, focus, I will make it colors to you. This one we are doing now, this one. Look, this one. Since this triangle also, since the height makes 90 degrees with the base, so it's right angle triangle as well. So you find h1 using Pythagoras Theorem again. So how many times? Look, we used Pythagoras Theorem to find the unknown sides. So h1 squared plus 3 squared is equal to 13 squared, which is the hypotenuse. Squaring root this using the calculator, you will get h1 is equal to 12.6 centimeters to 3 significant figures. Again, if I was fast here, we'll do again the same logic to find h2. Now this is 13, so this is 13. Some of students wondering, is this is it certainly 13? Yes, of course, I'll show you why quickly, which is useful here. So this is 5, so ED is 5, ED is 5, ED is 5, ED is 5. And FE is 12. From the question, the height is 12. So 12 squared plus 5 squared, as we did in this step, you'll get the same answer. This is, which is FD is 13 as well. So it's definitely 13. So this is as well as isosceles triangle, but its base is 8. Its base is 8, so it has different height. Believe it, dear students. I'm not the only one right in this word, but many teachers and instructors and students, they do this topic wrong. They don't understand, they miss between the heights and the dimensions in this shape. Good? So this is 4, this is 4, and again this is right angle triangle, the same we did with the first case. So H2 now, H2 is equal to 13 squared minus 4 squared under the square root. You find the answer. So H2 is 12.4 centimeter. That I did here, just I put the answers here with the blue, look at them. I replace each one with its value and H2 with its value here. This that I did. I do it in blue to make it easy to you to see it. What did I do? So I just replace the values in this formula, added by the calculator, getting at the end the surface area, which is 222.8 centimeters squared. I wish I did explain this as simple as I can. This is the hardest example and work for us today as well. Let's move to the other cases. Surface area of a cylinder. These are easy because they are formulas. You have to memorize them as IGCSE student. As an O-level student, you must memorize, but it's not bad to understand some parts. So the formula for the surface area for a cylinder is this: 2 pi r squared. Of course, when we say cylinder, what do you mean by cylinder? Solid cylinder, closed from both sides. We have to read the question well, because of this I did the example here different, to pay attention to this. Solid means it's closed from both. What does this formula quickly mean? 2 pi r squared is straightforward case. 2 pi r squared are what? The bases, the circles, these two. Why I draw this shape, I will tell you quickly. That I did here to explain this part, 2 pi rh, from where it came in mathematics. Okay. Cylinder, if some of you don't know, it's good to know. It's a rectangle first. Watch the recommended movie about how they do cans, Pepsi cans or any can, Copa can, any can, they make it plate first, rectangular shape, like this shape here, this one. Then we rotate this shape, we rotate it, we turn it about this line, the black one in the middle. What I will be getting if I do this? Assuming the length or this dimension is r, when you rotate, we have another r here, the same, rotate it and coming back, turn it, full turn, you will get a cylinder. If you turn, full turn, if you turn a rectangle, complete turn, you will get a cylinder, about a line. But you'll be getting 2r, and what you'll be getting now, the length, it was r, it's now what? The length of the circle, which call it the circumference of the circle in previous video, and you know this from previous stages. year 7, year 8. You know the circumference, C for circumference. Circumference of the circle, which is 2 pi r. 2 pi r from this part comes. Times h, which is the height. Which is the height. Look, the same. The height of the cylinder is the height of the original rectangle. How the questions may come? First example, or the only example of on cylinders on this. Find the surface area of a cylinder opened from top. Opened from top. Opened from top, what does it mean? You'll not be calculating it here, this opened from top. So, the 2 was here in the formula, and the surface area didn't appear here. I wrote only pi r squared. Why? Because it's one base, one circle. One base, one circle. So, the area of the base is the area of the circle pi r squared, which is given, r is given, plus 2 pi r h. Only that you'll be doing, you are replacing h with 10 centimeters, r with 3 centimeters in the formula. Pi r squared, pi 3 squared plus 2 pi r, which is 3 times 10, which is h. If the question says write your answer in terms of pi, we stop here. This is in terms of pi. Or you continue to write it or to 3 significant figures, you will get 217 centimeters squared. But is it wrong if you wrote 69 pi centimeters squared? No, it's not. It's not. Surface area of the cone. The surface area of the cone, the third that you are interested in the IGs. Again, you have to memorize it. We have to memorize, but it's good to explain some parts like I did in the cylinder. Surface area of the cone, its base, which is the circle. Its base, we know that the base of the cone is a circle. This circle that I'm coloring in blue now. One circle. Yes? Plus pi RL. Where L, it's a new quantity to us, a new value. It's called the slant height of the cone. This one, slant height. Slant, oblique, slant. Yeah? What do you mean by, how do you find the slant height? Always the height makes 90 degrees to the base. Don't forget this fact, always. So H makes 90 degrees to R. So this triangle is right angle triangle. So L is the hypotenuse of this triangle. Look how very important is Pythagoras Theorem. Very important theorem. Very old, very ancient theorem. Still very important. And we'll be using it in our exams. So since L is the hypotenuse, so L squared is equal to H squared plus R squared. So L is equal to the square root of R squared plus H squared. Let's do example in numbers. If the volume of a cone, if the volume given, when you say if given, you are given the volume of a cone, its base of a radius 5 is 100 pi centimeter cubed. What are we given? Then before I continue reading, so we are given the volume of the cone. The volume is equal to 100 pi centimeter cubed. Find the surface area or the total surface area of the cone. How do you do this? When you are given the volume, you can find H from the volume. Why? Because this from the previous video, previous lesson. Volume of the cone is what? It's third times pi times R squared times H. Third volume of the cylinder, if you remember. So this information helps us to find H, my dear students. Yes? I must find h to be able to find L, then I find the surface area of the cone. We are given R, so this will be third pi, 5 squared h is equal to 100 pi. Pi with pi, they cancel each others. 3 times 100, or use the calculator. So h is equal to 300 dividing by 25, 12 centimeters. Yes? 12 centimeters. Now we know h, now it's 12. The height is 12. So this is the right angle triangle, so we can find L now. Now L is equal to, or L squared is equal to 12 squared plus 5 squared, which is 169. So this implies that L squaring root 169, it is 13 centimeters. Then you write the surface area of the cone. Look, it's easy and nice, dear students. Is equal to pi r squared, which is the area of the circle, which is the base, plus pi rl. Just replace the values. Pi r squared, which is 5 squared, plus pi times 5 times 13. 65 pi plus 25 pi, it's 90 pi in terms of pi. Or if you want it in decimals or to 3 significant figures, 90 times pi, it's 283 centimeters squared. To 3 significant figures. The last one is the easiest one. It's good to finish something part hard with easy. The surface area of the sphere, only it's very simple, 4 pi r squared. I wrote to you 4 circles. What do you mean by 4? To remind yourself, to make it easy to you, to yourself to memorize. 4 circles. What's the area of the circle? Pi r squared. The sphere, 4 pi r squared. 4 pi r squared. Let's do a quick example on this. If the volume of a sphere is 226 centimeter cubed, if the volume of a sphere is 226 centimeter cubed, find the surface area of the sphere. Simple. The same thing. Solution. We must not memorize, I said in the syllabus now, but we must, because I did explain it in the last part. So we write the volume of the sphere, which is 4 over 3 pi r cubed, is equal to 226. Now by this, what you have to find? R, my dear students. I find R, then I find the surface area of the sphere. So we use the given volume to find R. How do you find R? We solve this for R. So we cross multiply. 226 times 3 dividing by 4 pi. You will get 53 r cubed. Let me write r at the end to not confuse you. So from here, r cubed is equal to 53.9 to 3 significant figures. We want r, so we do what? Third root, cubed root to this number. So we do third root for this answer. So r is equal to 3.78 centimeter. 3.78 centimeter. Then you come now. So surface area of the sphere, simple like this. is equal to 4 times pi times 3.78 squared. That's it. Times pi times 4. It is 179 centimeters squared. We can say the hard part was today only the first part. Make sure you understand. I make this title to you. You are like asking yourself, do I understand? Check that you did understand or not. So the homework, do it task at home. It's useful. When you do these questions, mean you understood well. It's good. First question, a cuboid has a height of y meters. The dimensions of its base are 4 and 3 meters. Its base is rectangle, of course, cuboid, be careful. If its surface area is 108 meters squared, find the volume of the cuboid. What's the volume? Question 2, if the volume of a square-based pyramid is 252 centimeters squared, given that the length of the side of the base is 6 centimeters, find the surface area of the pyramid. Find the surface area of the pyramid. I always wish you the best, and I wish I'll be part of helping you to prepare you for the exams. Regarding they will be certainly on June or May, or they will be delayed, but you have to be ready for like these types of questions, and you have to be good in mensuration. Hear from us soon with mensuration 4 to do more harder or complex problems. Thank you so much.